This is the second blog of the series Network Management, where we will be discussing NetFlow basics. And NetFlow is one of the very important concept in network management and security as well, because it gives you so much of data visibility, what is going in your network by looking into the deep into the packet itself. So let's get started with NetFlow basics. And I have prepared this document because the PPT format is gonna not gonna incorporate this much information, so I put it in a Word doc format. You can take a screenshot, otherwise I'm going to attach it with the recording itself. So what is NetFlow? NetFlow is a feature which collects packet, classify packets into flows, and measure flow stats as the packet enter or exit network interface. So it basically look at the packet which are entering or exiting network interface, collect them, classify them, and then we'll give you the stats. By analyzing the flow, what you can do, you can identify why, if there is any congestion, why is that. You can determine what kind of class of services are there, what kind of application you are running, what is this, my source and destination network, all those things. Good thing about NetFlow, since it is a part of iOS software itself, you don't need to define or install any external probes. And one misconception about NetFlow is that it takes a lot of resources and it can cause congestion, but that is not true. A full-fledged NetFlow put around 1 to less than 2% of load on your router. And if you want to reduce that load, you can use the technique like filtering or sampling, so that you don't capture each and every packet, but you sample it, or maybe if the packets which you don't want, you can filter them even before NetFlow capture them. What are the key component of NetFlow? There are two key component: NetFlow cache, which store all the flow information, and NetFlow exports that send NetFlow data to a external collector. What is a flow? A flow is defined as a set of packet having common properties. A flow will have all the common properties, and if there is a mismatch in those common properties, those are considered as two different flow. NetFlow defines flow by a combination of key field in the packet called flow keys. So the matching keys are called key field. Additional information can also be reported, but they are like non-key field, so they don't trigger a flow. Initially, when NetFlow was defined, it was a combination of 7 key fields: source IP, destination IP, source port, destination port, layer 3 protocol type like IP, OSPF, BGP, etc., TOS type of services, and logical interface, the interface it is using to either enter or exit. So if a flow matches all these 7, they consist of one flow. So if a flow has different field than another flow, it is considered as a new flow. NetFlow operates by creating a flow cache entry that contains the information of each active flow. So the key component of NetFlow is cache, where all the flow entries are stored, and you can visualize that by show IP cache flow. Few other concepts: flow timers. So there are 2 timers in NetFlow: inactive timer, flow that have been idle for specific time are expired and removed from cache. So if there is no activity for the flow for 15 seconds, that will be expired from cache and deleted. Then active timer. So some flows are really long lived, that means you see a lot of activities. So, but if that persists forever, that is also a problem. So there is an active timer for that. So if anything lived more than 30 minutes, they will be removed from the cache, and still if you see data coming for that flow, a new flow entry will be created. The advantage of this, once these timer expired, NetFlow group those packets and send it to external collector. Now NetFlow exporter. Expired flows are grouped into NetFlow export packet to transport them to network element to a collector. So there is an external collector who is expecting NetFlow data, so that it can do all kind of reporting and visualization. That's what our exporter do. An export packet consists of header and sequence of flow record. Header contains info like sequence number, record count, sys time. So there is a header and there is all those NetFlow information. NetFlow versions. NetFlow versions start with version 1, which was like long back, and then since then it has evolved quite a bit. So we have version 5, we had version 8, some are proprietary, version 9, and now NetFlow version 10 or IPFix. But NetFlow version 9 and now IPFix are most common in the network. So key difference of NetFlow 9, now it is a template based approach. So a template describes the record format and field attribute in the within the record. So basically, it brings the flexibility. So you can define what kind of template you want, and within that template, what are the fields. You can select those fields. Port wise, protocol export protocol uses UDP by default, and again UDP is a connectionless protocol, so reliability comes into mind. So now we have SCTP, which you can use, which is Stream Control Transport Protocol. It brings in some reliability, but still you will see most common use is to use UDP. New concept with since template based approach comes is flexible NetFlow, or fondly called FNF. So FNF allow you to configure key field and non-key field for the flow record. So now you can choose your non-key field also. So non-key field is not coming by default. You can obviously define your key field, but at the same time, you have flexibility to define a non-key field. And mind it that non-key field doesn't increase the flow record, because the flow consists of only with key field. The key field determine how traffic is attributed to a flow, and non-key field provide additional info about traffic in a flow record. A change in a non-key field does not create a new flow value for the majority of non-key, and majority of non-key are taken from the first packet. So it doesn't put any extra load on network. That means it's not increase the number of flow, and it doesn't capture all those non-key value from all the packet. Now let's see configuration steps for FNF, because nowadays everybody in that network using FNF, because it's template based approach, its richness in template and flexibility. So let's see how you can configure FNF. First, you define your flow record, which is a collection of all your key and non-key values. Then you define your exporter. Exporter define destination and transport protocols to which external NetFlow collector you want to send this data, and what protocol you want to use, UDP or SHTTP. That you define under exporter. And then the flow monitor is a umbrella which tie in flow recorder and flow exporter together. Flow monitor consists of flow cache basically, and flow cache is populated by flow record. So flow monitor calls for flow record, and at the same time it calls for flow exporter. As we are discussing NetFlow, I would like to introduce one more concept which goes hand in hand with NetFlow is NBAR. So NBAR is application recognition technique which can recognize wide variety of application by inspecting IP packets payload up to layer 7, and it uses the PDLM. So PDLM is kind of like its engine, which has all the data set, and this this help NBAR to recognize different applications and all those. So NetFlow basically it can if you run NetFlow alone, it can look at the application data and say, okay, this is the HTTP application, or this is the HTTPS application, but it cannot tell you that if it is HTTP, what website it is going, right? But if you enable NBAR, it can actually look deep into HTTP data and tell if it is a Facebook data or if it is some legitimate data kind of thing. And since this HTTP keep on increasing every day, a lot of websites are coming and this and that, this PDLM is also keep on updating so that they have ability to recognize new applications, and it can prove it can prove a very good security feature also, and it help you to define your QoS, like what you can analyze your network traffic within using NetFlow and NBAR, classify them, identify application, and then based on that you can define your QoS. So now let's see how we can configure NetFlow. So NetFlow router configuration. We'll go to router and do that configuration, but for your information. I'm showing the configuration here. So first we are going to define flow record. You can pause the screen and take a screenshot. Second, what you would like to do is a flow exporter. So flow exporter is where I want to send my NetFlow data and what protocol I want to use. So basically in this exercise, I'm sending a NetFlow data to a UDP director and listening to 2055. The flow monitor, again, the flow monitor is umbrella. So it calls for exporter and record, and at the same time define the timers, inactive timer, active timer, and then you apply your NetFlow on the WAN interface. So I'm applying it to WAN interface, which is going to another set of WAN aggregation router. Also, I'm applying to a VLAN interface where all my access layer subnet are terminating, and on this subnet, on this VLAN, I would like to define my nbar also. So I enable nbar so that it can look into the data, what it is receiving on this VLAN. So nbar config, NetFlow config, some verification. So let's go back to router itself and check. Let's verify the NetFlow on router itself. So this is our router which is configured for NetFlow. Let's see. Show run flow record. This is what I configured. So basically you can see my record name is live action. So I'm using live action to generate the NetFlow configuration, but you can generate have your own configuration. You can go to some website which can help you. If you're new to NetFlow, you can go to some website which can help you to generate a NetFlow configuration. Show run flow. The second thing is exporter. This is the exporter config, and third thing is show run flow monitor, which actually tie recording exporter together and define some timers. Where I'm applying this, I am applying this show run interface. One, I guess. Show interface description and to ISR show run INTG. This is where I'm applying this. So in my network, I have some data activity going on. Like there are two PCs, a couple of PCs who are sending TCP UDP traffic to them. So there is some network activity, and now we are good to do our verification for NetFlow. Let's see what we got here. All the NetFlow verification command in Cisco start with show flow, and you have to capture your flow, whatever you want to see. So I want to see the exporter first, tell you what is the source, destination, and this is all exporter info. The next thing what you would like to verify is your template, because as mentioned that NetFlow FNF is very template based approach. So let's see that we are in template. This is the template looks like. So basically the key thing is when router send the data, it first send the template so that exporter is aware of the fields what he should expect, and then he send the actual data. Okay, a lot of info you can play around. Then let's see the actual NetFlow. So you can see these are the flows: active, source address, destination address, transport protocol, everything. So 161, that means it's a SNMP data, port is SNMP. Then we have layer 7 unknown, the traffic which my traffic generators are generating. So I'm using random port, that's why it doesn't recognize that. And lot of other data you can see. Okay, Now, if you don't like this format, I better like this format, the table format. I'll show you what you can do with table format. So this same representation, but it's more human readable. So you can have all the flows in horizontal manner so that you can read that what is your source, what is your destination, and if I can enlarge my screen a little bit better, this overlap will go. So you really need a large screen because I'm using more collect field. But if you trim down your collect, probably you can get rid of some of these extra fields, and it will become more presentable. So these are all the flow infos going in my network. Not much activity, but still useful. And we also configured nvar. So let's see what nvar is giving us. So okay, show IP nvar resources. Now what I want to see is, so basically you can use show IP nvar resources to check how much resources you are using. We would like to see the protocol discovery, what all protocol I'm discovering. So this is it: SSH, SNMP, ICMP, BGP, DNS. These are the things going on in my network per interfaces. So it gives you per interface, and protocol wise, it gives you the protocol which are receiving the most traffic. So you can see these are the things. Not much activity in my network, but still kind of variety of protocol. SSH because I SSH to this, SNMP because SNMP is going to PRTG, some ICMP because of IPSLA, BGP is configured, and obviously the DNS traffic. So this is my NetFlow presentation where we verified in NetFlow config and verification on router. In next presentation, we'll see how a flow exporter visualize this data. We will be using Stealth Watch flow collector, and we'll use live action as a NetFlow collector and see the difference.